Hi, today we continue our review of Algebra 1 material by beginning to look at linear functions, which was a major topic back in Algebra 1, and I know you spent a good chunk of the year doing that. So, by the end of this first section, you should be able to explain the concept of slope in multiple different ways. We'll go over those. And given 2 points on a coordinate grid, you should be able to calculate the slope of the line that runs through those 2 points. So let's jump in with a little exploration. Suppose you have to call a plumber. He charges you $100 just for coming to your house, and then $120 each hour after that. Alrighty. Well, first way to explore something new like this might always be to make a table of values. So I took number of hours, 0, 1, 2, 3, 4, 5. I could go on if I needed to, but that's a good start. And I calculated the fee that the plumber would charge me. Now, just for showing up, that's $100. Hasn't done anything yet, hasn't been there. Just $100 for getting there. So after an hour, it's another $120, another $120, another $120, another $120, and so on. So that's what to notice. Each time the hour goes up by 1, the fee goes up by 120, which was that rate. Alrighty. So now let's look at a graph of this. Okay, so I took those points, plotted them on a grid, have my cost, or my fee charge anyway, here, going up by hundreds, and my number of hours on the x-axis going up by 1 hour each time. And I get this line. Well, first off, we can see why these are called linear functions. Notice, because of that constant rate of change, in this case $120, plot my points, and I get a line. It's right in the name, linear line. Alright, so some of that's easy to see. The $100 starting point down here, that would be the same. But where does that 120 come in? How does that play off? Well, if I go over 1 hour, let's see, that should be about there, I've gone up about $120. What if I went up at a faster rate? Suppose the plumber charged $240 an hour. Well, then my line would look like this. Notice it is much steeper because it has to climb much higher to get over to the correct point in only an hour. What if instead of that, the plumber would have charged only $60 an hour? Well, there's that red line. Notice how this time the slower rate produced a shallower line because it only had to go up 60 in that hour. So what we're looking at is that rate of change, in this case the rate of cost per hour, is what controls the steepness of this line. Switch over to this one. Here's that same graph again. It's going through the 100. It only goes up by 200s this time, but it's the same graph. If I alter the rate that the plumber charges, the line changes its steepness. Notice that initial $100 stays the same, but the steepness changes. So we have a line because in each case the rate of change stays the same. And if we change, and different rates of change have different steepnesses of lines. So what does that mean for us? The measurement of the steepness of a line is what we call slope. How steep the graph is. The steepness is connected to how much the rate of change in our situation is. And the original line, the example we've been looking at, We're changing by $120 every hour, so that is the slope, 120. Another way of looking at that, the rate of change, it's the ratio of the change in y, so how far up or down you've gone, compared to, compared to the change in x, how far to the right you've gone. If I switch back over to the graph, you can see that. So I've gone up 120. Oop, the one's not on here either. I go up 120 over 1. So 120 over 1. Because this is going to be the same because of similarity of triangles, basically. If I go up 240, I will have to have gone over 2 hours. 240 divided by 2, 120. That's all that means by that ratio. The phrase you probably heard when dealing with slope was rise over run. The rise is your change in your y values, and the run is the change in your x values. So now let's look at a specific example, which I'm going to bring up. Just a moment. Maybe. There we go. All right, so we want to calculate the slope between 2 points, -4, 7, and 5, -5. So remember that slope, which uses an m for some reason, I don't really know why, but probably the term for slope started with an m in some other language, probably German. Regardless, m is slope. So we need to do the change in y over the change in x. So let's look at the y coordinates, see if we can just do this without a graph. We started at -7 and we ended up at -5. So we've definitely gone down, but how much? Well, to find how much is between two numbers, you just subtract it. We ended at -5, we started at 7, so the change in y is -12. Now for the x's, we start at -4, ended at 5. So if we take 5 minus -4, that's going to be the same as 5 plus 4, which is 9. Reduce our fraction. The slope is -4/3, which means it goes down 4/3 every time it goes over 1. Or another way of saying the exact same idea is it goes down 4 every time you go to the right 3. That's the rate of change. How far it's changing on up and down over how far it's changing as you go to the right. On a graph, that is. For those of you who like formulas, you can look at this and go, well, I took the second y coordinate and subtracted the first y coordinate. When you're doing this, be sure when you do y's, you do a y and then on the other y, over the second x coordinate minus the first x coordinate. You've probably seen that formula and you probably have used it before and you've probably forgotten about it since it's been a while. And sometimes you might get confused, but just remember that what this is doing is figuring out these ideas. How much did y change by? That goes on top. How much did x change by? That goes on the bottom. And slope is just the ratio of those two values, which again is also the rate of change of whatever relationship you're looking at. In this case, the example we've been using this whole time, it was the cost of a plumber. A lot of things are linear, but let's say a plant is growing at the same 6 inches per week. Well, that's a linear idea. The rate of change was 6 inches, which means the slope, if you were to graph its heights over the course of a summer, the slope would be 6 in that case. Alrighty, I do not have the assignment with me here as I'm doing this, but hopefully you've seen slope is just a measure of the steepness of a graph, which is the rate of change of the situation you're in. And it's the ratio of how x or how y changes over how x changes. I even showed you the formula. And then for the other one, applying that formula, doing that calculation for that ratio is how you find the slope if you know 2 points on your line. Okay, thank you. And we'll see you next time with the next part of our linear review.